And today I want to show you, I want to start our session with a little demo. Let's create a file, call it main.tf. In this main.tf, we'll create a VPC. And we'll give our CIDR block to it. Pretty straightforward, right? Now let's say we have a developer or a stakeholder who comes to us and say, hey, I want two VPCs. I want them to be one of them be prod, second dev, or maybe even like dev, test, and prod, right? So not a problem. We can declare some locals for this. Let's say VPC TIDR equals, first one will be 10.0.0/16. Second will be 10.1.0.0/16. And 10.2.0.0/16. And actually, let's have one more just for the sake of completeness. 10.3.0.0/16. We use count, nothing new here. Whichever number of VPCs we declare will equal to the number of our VPCs, and this will be local VPC CIDR count.index. Very cool. We run Terraform apply. Very cool. We have created 4 VPCs. Let's imagine we started to deploy there. We gave it to our developers, to our testers. We even launched our production. And suddenly our boss comes to us and says, hey, we no longer need 10.1. Please remove it. Not a problem. Let's remove it. And when we run Terraform apply, what do you think will happen? How many resources it will delete? Will it create any resources? What will happen? Who can anyone predict what will be our Terraform plan? Vyacheslav, what's your opinion? What do you think?
Will match your configurations.
Once again, match configurations.
Yeah.
So we've created 4 resources. Yeah. Now we deleted one of them from this list, right? There are multiple opinions actually. I see people dropping messages in that count. Drop 4, create 3, as count is now 3. 2 will be created. Why created? Samira, why you think VPCs will be created? We are deleting one.
So while we are actually dropping off one of the CIDR range, probably the IPs would be changing, right? So I believe like the first one would be the same, but the second and third CIDR will be changed. So
yes, and this is totally right. We could have expected that only one VPC will be deleted, but in fact, even 3 of them will be deleted. 1 is deleted legit, and 2 of them will be recreated. Why? Because let me visualize it to the rest of the group to expand what Samira just said. So we have a VPC with 10.0.0.0/16 and one more VPC of 10.1, 10.2, and 10.3. So what we have here, an index. So what index, what count index will correspond to 10.0?
0.
Totally right. This means this will be 1. This means this will be 2. This means this will be 3. That's what we had. Now what is happening? Yeah, let's copy paste this. We are jumping right into in the middle, into here. However, this index does not go away. It simply shifts the remaining right part into like this. So what it will actually do is it will not delete this 10.0, but instead it will say, hey, index changed. Now 10.1 should be 10.2, like this. It is changing the CIDR so it matches the index. 10.2 now should be 10.3. And 10.3 will actually go away. Whatever was here will go away, and 10.3 will be updated with 10.2. Does it make sense now to everyone? Okay, then let's somehow fix that. And I'd rather run Terraform destroy. And I'll take advantage of different construction. We've already seen it before, called for each. I will code it right now and explain just in a second. So what it means, we have created a different data structure out of this list. We've created key value map. We've created a set. So let me show you what's inside. I will do this using test output. Yeah, we don't need it for each, just one. No, it's a set. 1 second. No, sorry, it will not work this way. I'll just explain it without this output. So what it did is that it created a structure similar to this one. And this happened within, I would say, Terraform memory. And let me tell you what will happen then when we delete, for example, this item and when we're using for each. Instead of index 0, 1, 2, 3, this unique IP address will be used as an identifier, and it will not attempt to make this shift. It will not attempt to shift the right part when we remove something from within the body. Let me demonstrate this to you. Now you can see it is just deleting one single instance and nothing else. But we can go even beyond this. We can reconfigure it. Let's say we want more properties, right? Not only VPC CIDR. We might go ahead and do something like this. Name equals prod. Name equals def. Name equals def. And this one we don't need. And here we can say x equals name equals name, and value equals each key name. So what it means? It will go through each element of these of this map, and we no longer need to set because our initial data type has changed. It will go through this array of objects. It will record into the each key on each iteration these top level element, which should be unique. That's why it's called a key. And value will be everything that's within these brackets. And we can declare unlimited number of properties. And these are available through each, sorry, it should be not key, it should be value. And these will be available through each value. And this one should be equalized. Let me expand these into even more. Let's say DNS equals true. This one DNS will be false. And this one DNS will be true. Let's say we want to control if we want to enable or disable DNS support for our networks that we managed using this construction. Enable DNS support equals each dot value dot DNS. So and let's run Terraform apply. Yeah, and as usual, I make stupid mistakes. One second. Yeah, probably because of this. Ah, okay. Sorry, brain is completely turned off closer to the evening. The error was saying precisely what I need to change. I had third octet while I should have had second one for VPC CIDRs. And yeah, let me show you. Yeah, it will destroy one, which is 10.3/16. And let's actually return it, so we'll have it as well. Let's say it will be QA. DNS will be false. Why it says it will be destroyed? Not in the for each map. And which one will be recreated instead? Why it says, yeah, I forgot to change it to 3. One more time. Yeah, now all looks good. So for 10.3, it will add this tag, name equals QA. For 10.2, it will create it with this tag and with enable DNS support. 10.1 will be created, 10.0 will be updated. So these constructions allow you to, let's say, create a module and go even beyond. You won't even have to repeat the module calls. Let's say you have some, I don't know, application which requires multiple buckets, multiple databases or DynamoDB tables. You can create one single reusable block, one single reusable module of whatever object you need. You creating this data structure which contains all the parameters of it. You push it into your configuration using this for each construction, and you applying it, and your code is, I would say, super dry. You only change whatever needs to be changed and don't ever repeat yourself anywhere. I know it might sound slightly complicated, but hopefully, at least to a certain extent clear. At least it has sparked an idea, and yeah, you might wanna rewatch it afterwards, or of course, if you have any questions right now, and hopefully you do have, so please don't hesitate to ask. So is it clear? What questions do you have? Yes, Samira.
Are these each key and value the keywords of the Terraform?
Yes. Each key and each value are keywords. Each key corresponds to this. That's the key. This or this, that this will be recorded into each key, and it should be unique. This is how Terraform will find. It's like an address in the library. Each value are the contents of whatever under this key. So and from here we can define anything that we will like. Each value DNS will correspond to this DNS field. Each value name will correspond to name, and so on and so forth.
Okay, so for each is actually a for loop.
Yes, it's a for loop, but I would say it's a Terraform implementation of a construction similar to for loop. Terraform is a declarative language. There is no concept of loop, but there is for each that's very similar to it.
Okay, makes sense. Yeah. Thank you.
Yeah, of course. So, having said that, question to you guys: what will happen if we remove this only empty brackets? Any ideas? Okay, then if no ideas, let's just test it out. It will say it will destroy everything. And this is another thing that I wanted to show you. We had loops, and we could have a replacement of or implementation of conditions. So for those of you who are unaware, in programming terms, condition is something that explains how computer should make a decision. For example, A equals 2, B equals 5. If A is bigger than 5, then, for example, you perform action print A is bigger than 5, and otherwise you say print B is bigger than this one will be B. So what we'll do? Yeah, in this case, A equals to B equals 5. It will show this one. Otherwise, if we change this, example 101, otherwise it will go here. So, but for example, what we can do, how we can implement this in Terraform? We can just declare a variable, for example, create VPC, and say true or false. And we might want to say if create VPC equals true, then we'll run we'll create a VPC. Otherwise, we will not create a VPC. And both for each and count allow us to implement this structure. It allows us to conditionally decide whether a VPC can be created or not. So let's do this. I'll declare a variable var 8 VPC. And instead of for each, let me remove this. I'll only keep CIDR block. Let's say this, count equals var create VPC. Zero one. Let's expand it better. What it means. So if a variable create VPC equals true, if this evaluates to true, then count will be 1. Otherwise, it should be 0. So let's declare form.tf vars create VPC equals true. Let's see what it will suggest. It says 1 to add. Yeah. Why? Again, because create VPC equals true, then choose this 1 or otherwise 0. We can, let's say, change this value, and then it will create 10 VPCs right now. Or we can even declare some additional variable. Let's say local VPC count. Let it be 3 this time. There we have it. It suggests to create 3. But if we set this to false and run Terraform apply, it will not create anything at all. So, and this is, and this I'd say I'd frame it this way. Ones of you who were curious enough to go into main TF in any of modules, perhaps you've noticed this construction. And in fact, it is very similar, but it evaluates multiple decisions. It evaluates multiple conditions. So if a weather is good, if you have free time, and if you have good health, you will go outside for a walk. If any of them does not true, you will stay at home. If we have a variable create VPC and length of the variable secondary CIDR blocks is bigger than 0, and then the number of these resources will equal to the length of variable secondary CIDR blocks, but if either create VPC equals to false or length of VPCI CIDR block is equal to 0, nothing will be created. And this is how you create, let me show you. I'll go read. I'd rather call it DC. You'll create conditional logic very similar to tree, right? If condition A is met, you go one way. If condition B is met, you go another way. Again, 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 and again. Until very certain precise decision. It will make total sense for one of you who's familiar with basics of computer algorithms. Does it make sense? Okay, cool. Very good. Next thing that I want to demonstrate to you, and that you will very often notice in, first of all, when you read code of others, when you read open source Terraform modules, is dynamic block. Let me explain to you what it means. So I'll create a security group. I take a very simple example directly from documentation and remove all these. Run Terraform apply. Would allow me to run it without description. Very interesting. Most likely, yes. Very cool. So we have a security group, but it is empty now. And in like a regular scenario that we've did before, we have created the ingress block, right? Which says like 443 from protocol TCP, IPv6 we don't need. Description, let's also test whether it allows us to do this or not. And CIDR block, just for the sake of this simple example, I'll hardcode 10/16. Terraform apply. Yes. Cool. We've created our ingress rule. But what if we want to modify it dynamically, or what if we want to parameterize it, or what if we want to create a module that dynamically accepts, for example, ports and IP ranges that we want to that we want to use? We could use a thing called dynamic. And what it actually means is essentially it repeats same configuration that we had in our for each, but for each use for top level resources, and dynamic block uses these, I would say, lower level blocks within a resource. And let me write it further so I demonstrate to you how it works. So we will define. Yeah, let's clean up a little. We no longer need this. We will remove Terraform CF and VPC count is no longer needed. Instead, we'll have a map called VPC, like security group rules, let's call it. And let's say this 443 calls. How to call it? 1 second, let me think. Okay, let's just have it. Let's just have even simpler example with just ports. For 380, let's say 22. Within dynamic ingress, we'll have for each to set port numbers. And from port will be each key. To port will be as well each key. So yeah, and one more thing. Within this dynamic, there will be the block called content that basically contains everything that standard block without dynamic should have had. Something like that. Run Terraform apply. Sorry, 1 second. It will be not each, it will be. Sorry, I forgot. Give me just a second to remember this. Yes. So what we've done? We've created this list of ports and dynamically passed it into a single ingress block. And this created these 3 rules. In a standard setup, we should have repeated this dynamic block 3 times. The question, actually multiple questions. Is it like parent dict whose item values is child dict with additional items? Yes. It's a dictionary of dictionaries. Do we always have to use toSet with for each statement? No, we don't have to always use toSet. We need to use toSet only when we want to iterate over a list. Local port numbers, this is what we fixed over here. Any additional questions? Okay, then we will move forward to the next topic for today. Today we have quite a lot. So you've already seen these toSet or length. What else we had? Apps path. No, we didn't have this one. Oh. And I used them even today. And let me explain what it is. This is the thing called Terraform function. And what is Terraform function? Terraform function is something that accepts some input, processes this input, and accepts and produces the output. For example, there is a function that allows us to join an elements in the array. For example, let's say A, B, and C. And I will test the output it produces using regular Terraform output. Value equals join. And we'll have it as a separator and a reference to locals local dot numbers. ABC, yeah. What output it will produce? A dash B dash C. Or let's say we want to split some line that we have. For example, keep your garbage separately. And there is a function that is doing exactly opposite, like split, separator, local line. Here we are. It produced a list that has each element separate as a separate element. We can in turn, for example, connect the element number, let's say 3. Let's try this. And this will be just word separately. Or we can pass the result of this function into another function. Let's say we want to first split this line and then replace it with some other character. So this will be join separator. Let's say this will be hash sign. And we will pass to it result of split. Run Terraform apply. And here we have these hashtags. And for example, what we can do next? There are unlimited number of different kinds of functions. Let's say we want to create some, let's say, what's the best example? Yeah, let's create MD5 hash out of it. And now it has transformed into this. And whenever you read the code that someone has written for you, let's open Terraform VPC module again. So you should not be scared away by these complex constructions. These just go to the middle, yeah, where it does not reference some other function, right? Try to make cognitive effort and calculate what it should have returned, interpolate it here in your mind, and then you will understand what this function is doing. And there will be always different functions, different conditions. So what this mean? This means if variable enable IPv4 and just having this variable enable IPv4 means like if it's set to true, it will be true. If it's not set to true, it will be false. If enable IPv6 is equals to true, and if use IPAM pool variable is not true, then the final result, which go into assign generated IPv6 CIDR block, will be true. Otherwise, it will be null. What other cool and interesting functions would we think of? We can read something from, let's say, file. And here we are. Now our value consists something that we've read from this file. We can again apply conditions, do different conversions. Let's say we want to say we have a local saying create MD5, or it's better. Let's rather have it as a variable. Variable MD5 default equals true. And let's come up with, let's say, var MD5. Then it will be MD5 at this file. Else it will be just file spoon txt. So in current setup, it will evaluate that MD5 is equals to true, and then choose this. In alternative case, if we set this to false, it will not aid this hashing. Does it make sense? Any questions? Okay, looks like either nothing was clear at all or everything was exactly crystal clear and no additional explanation is needed. You can find the full index of functions into this page. You can just search Terraform functions and it will give you this page. There are different kinds of functions, type conversion, numbering, hash and crypto, for example, MD5 that we had. There are separate group of functions for building your subnets, for calculating your subnets. Okay, and Sanjeev, there is ask for you to demonstrate lookup function. Yeah, of course. Let's do this. For lookup, we'll need a key value dictionary. Let's say cars. Uh, let's say we have, and it's not a variable. Let's declare it as a locals. Locals inventory. Yeah, should be good. And using lookup, we are querying our dictionary by required key. It will be local dot inventory. Let's say we want to find Mercedes, and let's try this. Must not be quoted. Okay, we will not quote it. Here we are. It says color black, engine gas, type car. And then we can, for example, query which color it has. It will say black. But essentially, lookup is equal to this syntax. It just extracts some value from the given map. There we have it. And the difference is, let's say, like that. Now it will return an error saying the given key does not exist. And in case of the lookup function, we can also say what will happen what value will be returned in case of key is missing. And we can't query color because does it exist that does not have this property. There we have it. It says does not exist. Hopefully it will help you. Any other questions, Boris? I see you have a hand raised. What's your question?
If you look up a property that multiple records have, what will happen? It'll display multiple records.
No, the map should have unique index. These, and these should not repeat.
Right, but can you? Okay, so I guess you cannot look up by a type of a vehicle.
No. That's not how it works. It's I would say even against the concept of map in general, not only in Terraform. Map is some short index and the object that's located by its index. If you come to the library and ask librarian to tell you to find you a book that says "Once upon a time there lived the king," or some other phrase, right? He will, the librarian will not accommodate this request, right?
Too ambiguous. I got it. Okay.
Yeah, you need to give a title, not some piece of content, right? So same situation here. Hopefully it didn't overwhelm you too much, and hopefully starting from today, where it is. Hopefully this will start making sense for you a little more. So what I encourage you to do after we finish the session is go to GitHub, open some big open source modules, and try to read it. Try to, I would say, open the envelope of a function and decipher what exactly means and what value under which circumstances will go into which field. And today's lecture should be capable of helping you a lot with this.